of various things, like all different kinds: civil engineers, mechanical engineers, electronics engineers, computer, aerospace. Everybody, there's a requirement for various kinds of engineering expertise. Um, Moving to the next slide. So now we talked about what do the engineers do, what are the engineers, what is engineering, what do they do, what are the various kinds of engineering, and now we're going to talk about who the engineers are. So as a question, well, the answer is written, and now we're going to make it a little interactive. um, who are some of the most famous engineers? So I don't know if all the attendees, you can unmute your mic and you can comment on it, but this is kind of like, I mean, the people who are more Marvel universe type people, they probably will like Tony Stark more than Bruce Wayne. Bruce Wayne is, by the way, Batman, more, the DC universe. So these two, Tony Stark and Bruce Wayne, are the epitome of engineering in their, own Marvel universe versus DC universe, because Iron Man does not have superpowers. Iron Man created those superpowers by engineering things that existed. Now, of course, there is some fiction in it, but a lot of things can be done. I mean, you already know that there is a backpack that you can use to fly around. That's already has been engineered. Okay. Now, of course, certain things, there are materials that are very strong. There are things that you can wear to give you more strength in terms of being, like a mechanical robot kind of thing. A lot of it is fictional, but these are all based on reality. It's not based on magic, it's not based on complete science fiction. It's all based on reality, as opposed to, let's say, in DC universe, in Marvel, Thor is a completely fictional character. Okay. um, Hulk is technically a fictional character, but Tony Stark or Iron Man is based on science and engineering, and he's an engineer by profession, technically, right? Similarly, Bruce Wayne, the Batman. Batman has no powers compared to Superman, for example, no inherent powers. Batman relies purely on feats of engineering, whether it's about creating his wings, which uses current to make sure that the material becomes solidified and it can be used as a wing. By the way, these are all based on real engineering feats. You have these kind of materials, whether they can be used in an industrial sense right now is a different thing, but there are materials like that. So things like that. So then a real life example, Elon Musk, you probably everybody knows who he is. Um, he's the owner of Tesla and also SpaceX, and all these. So the new kind of cars, the new kind of space rockets that are being made, these are all being made by engineers. So Elon Musk would be considered like an engineer who's very famous these days. Uh, Next, I put the names of Isaac Newton and Thomas Edison. Anybody, by the way, somebody, if you want to make a comment, can anybody tell me if Isaac Newton was a scientist or an engineer? Isaac Newton was mainly a scientist because he started out with theory, but he did create some. I mean, like, for example, some of his experiments could be thought of going towards engineering as well. But you're right, Isaac Newton is actually mainly a scientist. Thomas Edison, on the other hand, Thomas Edison is the guy who created all these electrical system, like, I mean, the light bulbs and all these kind of things. So he was mainly an engineer. He did not develop the theory about electromagnetics. He created products based out of that. So Isaac Newton is generally a scientist. Thomas Edison is generally considered an engineer. However, both of them crossed over as well. Thomas Edison did a lot of science work, analytical work before he created something. Isaac Newton thought of it or theorized things, and then translate, did some practical things as well. Albert Einstein, Isaac Newton. Albert Einstein is considered purely a scientist. He because he was the kind of guy who only thought of things that are not even we're able to see. So all his theories mainly were all theoretical and science related. However, even him, Albert Einstein, even one of his theories translated into a very common product these days. Anybody can guess how is Albert Einstein theory related to practical engineering? Because all these other theory about gravity and relativity and you know space travel, all the theoretical stuff, yes, it's out there. I mean, people have now been able to observe the black holes that Einstein predicted through his theories, but those are not necessarily practical everyday things. Can somebody give me an example of an everyday thing that came from Einstein's theories? Anybody? Aisha, is anybody putting anything in chat? Okay, Aisha, do you know?
No.
Um, so, so you know the photoelectric effect, right? The photoelectric effect came from Einstein theories. So the photoelectric effect is how the solar cells technically work. I mean, the light creates electricity. So that came from his theories. And in the end, the last one, the Wright brothers. Do you know who Wright brothers are? Anybody knows who Wright brothers are?
Yeah, people are saying yes.
Yeah. So who are they? Anybody can answer? No. Did anybody answer, Aisha, or no? Okay, I'll talk about it. So Wright brothers were the inventors of aeroplane. So they're the ones who invented the aeroplane. They were not scientists. Somebody else developed the science about how aeroplanes fly. That was developed earlier, but nobody translated that into an actual working machine. So the Wright brothers are inventors who are known as the inventors of the aeroplane. They created the first aeroplane and they flew in it. So that's where what I'm trying to point out, that a lot of scientists will put together the theory, and then engineers come and take that theory and translate that into a product. So these two things, science and engineering are related to each other. One talks about the nature of things, the other talks about how to create new things out of it and improvise existing things. So does that make sense? Uh, any other question? Otherwise, I'll open it up for open discussion. I want to have some open discussion, ask any questions in terms of career path. So let me talk about the career path as well. So my background, for example, is in electrical engineering. I did my bachelor's, then my master's in electrical engineering. Electrical engineering is a lot more specific, of course. We deal with things to do with telecom, things to do with uh, your computer, your telephone, your TV set, your audio set, um, any piece of electronics that you have has electrical engineering involvement in it, mainly electrical engineering involvement in it. But is it only electrical engineering involvement? I want to explain to you how things work. So take the case of your cell phone. Just let's talk about the cell phone. Okay. because everybody uses that all the time, all the day, right? So your smartphone, it involves electrical engineers who ensure all the signaling goes properly, um, whether it's signaling from your phone to the cell tower or inside the phone. Inside the phone, there's a lot of electricity running around. I mean, how do you think all these applications work and all these messaging works? You actually type something, that what you type gets translated eventually into electrical currents, and those currents take it from one place to the other, uh, whether inside the device or eventually through radio waves that are converted from electricity into radio waves to the other side completely, right? But anyway, all that involves electrical currents and electromagnetic waves. So that's all part of electrical engineering domain. But it's not just that. You know that anytime you use any electrical device, it has a tendency to heat up, right? So you need mechanical engineers to make sure that the product that you make, the actual phone box with all the electronics in it, has proper uh, design so that it can be cooled down. It can, it has something called a heat sink, or in terms of some element that can radiate the heat away so that it does not destroy the electrical circuits in there. So it is very important, if you design a phone or a laptop without considering or without consulting the mechanical engineering aspect of it, you can create a very good device, but you turn it on and in an hour it might burn itself because you didn't consider the heat aspect or the mechanical aspect of it. Then on top of that, the materials engineering, the material folks, they help in making sure you use the right kind of materials to make sure that it is light enough. So if you have your cell phone and it weighs like a brick, it's not as usable, right? So they've come up with better and better materials which are light as well as strong enough so that it doesn't break all the time. If you make your cell phone out of just cheap plastic, it will break every second day. It'll probably just break up. So they come up with uh, materials that are both light and are strong enough to make sure that your cell phone is housed in those kind of materials. So these are the things, the various things. Similarly, let's take an example of a vehicle or an automobile. Most of it is mechanical engineering. However, there are electrical systems in the car. There's an electric battery, there's ignition is done electrically, there's a lot of electrical systems. So it's not just, you know, a mechanical engineer who's involved. A mechanical engineer and an electrical engineer both are involved. Take the case of an aeroplane. It's not just an aerospace engineer. You have aerospace engineers, you have mechanical engineers, there are electrical systems, so there are electrical engineers involved, and whatnot. Look at the case of any huge building. Let's say you're just doing a house, making a house. You don't need just somebody who builds the structure. You need the electrical system in there and whatnot. So all the buildings, they require civil engineers and electrical engineers, mechanical engineers, everybody combines, right? So civil, mechanical, electrical are three of the bigger fields, but all the other fields are equally important and equally, they're also utilized as well. So that's in terms of, if somebody wants to develop a career as an engineer, they have to look at um, what what subjects maybe are something that are more towards their liking, and if they want to go towards that. For example, even inside physics, my growing up, for me, I was more interested in things that I could not see as opposed to things that I could see. So I was more interested in electrical or electromagnetics than in mechanics or mechanical engineering aspects, because mechanical engineering are typically things that you can see and you can fix. Electrical, you don't ever see an electron running around, right? You don't ever see it. So it's more conceptual, more theoretical, so things like that. So you can decide if you want to pursue engineering, you can decide based on what topics you like better in terms of deciding what kind of engineering you want to pursue. So anyway, with that, I'll just stop my presentation, and we'll open it up for discussion. Is that okay, Aisha?
Yeah.
Okay. So now, anybody, any questions? Feel free. No. Remember, there are no stupid questions. Okay. They can be stupid answers, but the questions are not stupid. So it's the onus is gonna be on me. You can ask anything. Go ahead. Anybody?
I have a question.
Sure.
So, would material engineering be involved in like architecture or not? In building things, like buildings.
Good, very good question, and I'll explain it to you. So material engineering is involved in selecting the kind of material that you would use for building. Civil engineering will be involved in the structural aspect of it. I'll give you a simple example. Um, you want to build a better house or strong house. What kind of material, what kind of metal can you use, what kind of wood can you use? Those are technically, they will come under from the aspect of materials engineering, right? They would emphasize in terms of what materials are stronger, what materials are fire resistant, and stuff like that. But then the civil engineers actually take that information and then build out the house. So in a in the direct way, civil engineers are responsible for building the house. The material engineers are involved indirectly. Does that make sense? They're indirectly involved because they're involved in terms of selection of the product of the or the strength of the product that civil engineers will use to build it out. Make sense?
Yeah, it just sounds like material engineering seems a lot related to science because they
It
don't.
is. You absolutely have a good point. There are certain fields that are much closer to science than engineering. Even electrical engineering, I did my all my background. We did mostly 80-90% of my work was mathematics. It was all mathematical theoretical, right? Not practical. So you are absolutely right. There are certain kinds of engineering which are more closer to science, pure science, than pure engineering, but they cross over. That's why I was trying to point out that they do cross over a lot. Yeah, but that's a very good point. So you're right. Civil engineering, the way it is utilized these days, is pure construction and engineering, because the scientific principles over many years have been solidified, right? So there is not too much of a variation. They already know the scientific principles. They know what causes stress, what product is behaves which way and that way. But that doesn't mean that there's no improvement going on. So you are like for example, uh, 50 years ago, you did not have uh, buildings that had fiberglass in it, right? Now you have things that are made out of fiberglass as a roof as well in places. So fiberglass came from materials engineering, which is then utilized by civil engineering to do the other work. Does that make sense? Okay. Any other question? Or you can have another question. You're on mute, I think.
Uh, that was it.
Okay. Good. That was a good question. Anybody else? Would it be rude to start picking on people? No, I'm just kidding. I'm not gonna do that. But anyway, feel free to ask any other question if you want. Does anyone here want to be an engineer? Yes, that's a good question. Do you want to be an engineer? Anybody who wants to be an engineer? How about a scientist? Does anybody want to be a scientist?
I'm thinking of being like a bioengineer, but I want to lean more on the science version of it than the engineering part.
And that's a very good thing to have a clarity in terms of what you want to be doing. But keep in mind, some of these things are not completely disconnected. They can be combined. For example, you can do biomedical engineering. One of my friends did that. He was a doctor, an actual expert in biology, as well as he did on the side biomedical engineering. So he was in a unique position to um, you know talk about how human body functions from a mechanical point of view, like stress point of view, things like that. So you don't have to do either or. You can do a little combination of. These days it's very easy to have combination of both, right? So you can do theory as well as practical implementation as well. It all depends on where you want to. Keep in mind, uh, if you like to build things and see the things being made as well and try to improvise that kind of leans more towards engineering. But that doesn't mean that scientists are not involved. But if you prefer just doing theoretical stuff, that leans more towards science. That doesn't mean that engineers don't do theory. Engineers do theory, but because they use their scientific knowledge to develop theory, but then eventually they target that theory towards improving an engineering aspect. Okay, anybody else? You are you the only one who wants to become an engineer slash scientist? Anybody else? Nobody wants to go into sciences either.
Is programming more of a type of science or a type of engineering?
So actually, it's 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 classified as computer science, but it's kind of like engineering. It's not like now cognitive sciences is considered pure sciences, but programming, because programming is done on an existing compiler which has already been like it follows set rules, right? So it is, I know they use the word computer science, but technically it is kind of part of engineering as well. And that's where sometimes these classifications get blurred. I as part of my electrical engineering, I did so much mathematics in school that sometimes the mathematics people would not have done those specific things, because things get blurred a lot. So do not think of engineering as something that excludes science, or do not think of science that completely excludes engineering. um, the best way for a computer science, or to become a better computer scientist, is to have a background in maths and computer science and computer engineering, so that you can really develop everything. But not it's not easy to do. But what you could always do is take courses of each expertise. You don't have to become you know a, do an entire degree in electrical engineering or entire degree in computer science, but you do courses, take courses in maths, take courses in computer science, and take courses in computer engineering, and combine the knowledge. So sometimes you could mix and match as well. But remember one thing, certain things are, like for example, um, pure physics, theoretical physics, like especially about particle physics or astrophysics, is is more theory. But when the particle physicist really needs to test out the system, what do they do? Where do they go? They can't do it on paper. Where do they go? They go to these accelerometers, or the particle accelerators, which are built with a combination of physicists and engineers. If the engineers are the one who build it, engineers will be the one who uh, do this testing. So, for example, this, all the particle analysis, all the new particles that they keep testing, these are being tested by engineers under the guidance of the physicists. Make sense? So it all combines that. So, there's a lot of fields have aspects of both. Even biology is not something that is completely, because the biomedical engineers, they combine aspects of biology with aspects of structure, and combine the sciences together. So does that answer your question, Aisha? Or did I confuse you more? You can ask a follow-up question if I confused you.
Oh, that makes sense.
Okay. Anybody else? Okay, we can wrap it up. So thank you, everybody, and have a lovely weekend.